Hello everyone and welcome back to another video provided by SVSU's online tutoring. My name is Joel and we will be continuing on with section 8.1, solving quadratic equations, factoring in special forms, and the topic this time will be the square root property. So this is a fairly straightforward and simple new property to understand. So let me go ahead and paste that in for us. So we have the square root property right here, and it says that the equation u squared equals d, where d is greater than 0, has exactly two solutions, which are u is equal to the square root of d and u is equal to the negative square root of d. And so they also say that the solutions may also be written as u is equal to plus or minus the square root of d. And this process is known as extracting square roots. So just to see the algebra on that real quick, a proof, in other words, I guess you could say. If we have u squared equal to d, what we want to do to solve this is subtract d on both sides, okay? So that way we'll end up with u squared minus d equaling 0. And then we want to factor this. So to do that, let me draw that arrow a little better. We want to think of two numbers that when multiplied together will give us u squared, and two numbers that multiplied together will give us negative d. So for u squared, it's just u and u. But for d, because this is negative, we will have the positive square root of d, okay, and then minus the positive square root of negative d, and that equals 0. And when we go and FOIL this to show that it works, we would have u squared and then minus u times the square root of d, and then our second term will be u, positive u times the square root of d, and then we have the square root of d, times the square root of d, okay, equaling 0. And so these two terms cancel because they're opposite sign, and so we have u squared minus the square root of d squared. And if we remember back in chapter 7, when the index of our radical is equal to the same power, well, they just cancel each other out. So we're left with u squared minus d equaling 0, which is the same thing that we started with back up here. Okay? So just to go through some quick examples, let me go ahead and now get rid of this. If we go ahead and look at some examples, if I have 4x squared equal to 16, I can't right away write a solution. I have to simplify this first. So to do that, I just divide both sides by 4, and then I'm left with x squared equaling 4. Now I can take the square root of both sides, and since I've done that, I know that x will be equal to plus or minus the square root of 4. But 4 is a perfect square, so we can simplify that down to plus or minus 2. And so that would be our answer. Another example is if we had x minus 3 squared equaling 7. Now what we have to do is that we have to take the square root of both sides. So we have x minus 3 equaling plus or minus the square root of 7. And then all we have to do now is just add the 3 to both sides. And so our solution would look like x is equal to positive 3 and plus or minus the square root of 7. Or if you wanted, you could write x is equal to 3 plus the square root of 7, and x is equal to 3 minus the square root of 7. Okay? The final example that we can take a look at is 5x minus 7 squared minus 10 is equal to 0. So the issue here is that we're not in our general square root property form. So in order to do that, we have to add the 10 to both sides, okay? And once we've done that, then we're able to take the square root of both sides to solve this type of quadratic equation. So we have 5x minus 7 is equal to plus or minus the square root of 10. And so I want to begin isolating my variable, so I have to add 7 to both sides. I'm going to continue writing that over here. So we have 5x is equal to 7 plus or minus the square root of 10. And now all we want to do to isolate x is divide both sides by 5. So we have x is equal to plus or minus, x is equal to 7 plus or minus the square root of 10 divided by 5. And that would be our solution. Okay, that does it for this video. In the next one we will discuss quadratic equations with complex solutions. So it's there that I imagine we'll begin to see some of our special forms that this section points out. Alright, see you next time.